Hey guys, it's Miss Johnson, and today I am here to bring you our video for Unit 7, Note 7. Today we are putting together the two halves of the unit that we have learned. The first half of the unit we talked about combinations and permutations. That was calculating the number of outcomes that a certain situation could happen. And then the second half of the unit we talked about calculating probability. Today we're putting those two things together. We're going to be calculating probability with combinations and permutations in them. So basically, if you're choosing more than one thing to happen, you have to have combinations or permutations in your probability equation, in your probability fraction. So let's just go back to combinations and permutations and talk about what those are. So combinations was the formula NCR, and it looked like that, n factorial divided by n minus r in parentheses factorial with that extra r factorial on the bottom. This is when order was not important. So some example of things that fit this was cards, groups, anytime you're talking about groups of something, teams, committees. Okay, so anytime you were working with something that the order didn't matter in which it was placed or chosen or whatever, then you were using combinations. Okay, then we also have permutations, which is NPR, and that is missing that extra r factorial in the bottom. That's just n factorial over n minus r factorial. And this is order is important. Okay, or order matters. So this is when we were looking at things like ranks, placings, okay, like first, second, third, gold, silver, bronze. You get it. Anything that had to do with order mattering. Yeah, ranking something, placing something, different jobs. So like president, vice president, secretary, treasury, those are all different jobs. So those have to be the order matters in which you're picked because you're serving a different function, you're performing a different job. So that's just how we decide to whether to use combinations or permutations. And again, we're only using combinations or permutations where more than one thing is being chosen at a time. So now let's talk about how we can put these things into probability. In number one, it says a combination bike lock requires a 3-digit code made up of the digits 0 through 9. No number can be used more than once. So now we're going to look at the different parts of this question. The first part says how many different combinations are possible. Well, the order matters because you have to put the combination in the right order in order to open the lock. So this is a permutation question. Okay, and we have 10 different digits because we have to count 0 as well. And we are choosing 3 of them. So this is 10p3, which looks like 10 factorial over 10 minus 3 factorial. That's 10 factorial over 7 factorial, which is really just 10 times 9 times 8 because 7 on down goes away. So I end up with 720 ways. Okay. Now, this is going to be the total. This is our total number of ways for the rest of these probability questions, okay? Total number of ways for the rest of the probability questions. So then when I look at part B, when it says, what's the probability that all of the digits of the code are odd? I need to figure out how many ways can I pick odd digits, okay? And divide that out of the total. So that's what I'm gonna do first is odd digits. I got to figure out how many ways. Well, how many odd numbers are there? In 0 through 9, there's 1, 3, 5, 7, and 9. 1, 2, 3, 4, 5. So there's 5 odd digits, and we are going to pick 3 of them. So that's 5p3, which is 5 factorial over 5 minus 3 factorial. That's 5 factorial over 2 factorial, which is 5 times 4 times 3, because 2 and 1 are going to go away, which gives me 60. But now we're looking for probability. So we just calculated the top, we just calculated the successes of that probability. So if I look at the probability of having odd digits, my probability is 60 out of the total, which is 720 that we found up here in part A. So 60 out of 720, I divide those two, and I guess I should make these approximately equal to because I need to round here. That's 0.083 for my probability. If I look at part C, the next question, what's the probability that the first digit is a 3? So what I need to think about is what would that look like? I have 3 digits in this code. I want the first one to be a 3, and then the second one can be any number and any number. Well, think about how many ways you can pick a 3 out of those digits. There's only one 3 in the whole thing. Then once I use that one digit, I only have 9 digits left because I started with 10. I used the 3, and now I only have 9 left. Then after I place one in the second spot, I have 8 left. So I have 1 times 9 times 8, which is 72. Those are my successes. So then my probability of the first digit being a 3 is 72 out of, oops, 720 is my total. I almost wrote the total on the top there. So 72 out of 720, which is 0.1, and that is equal to, because we don't have to round there. Then if I look at part D, the last part, what is the probability that the code is 1, 2, 3? So now if I'm thinking of the code 1, 2, 3, that has to be a 1, that has to be a 2, that has to be a 3. Well, there's only one way that you can pick a 1. There's only one way that you can pick a 2 because there's only one 2 in the whole list. There's only one way that you can pick a 3, and 1 times 1 times 1 is just 1. So this probability of the code being 1, 2, 3 is equal to 1. I only have one success. There's only one way that I can have that code. Out of the total number of codes, which is 720, 1 out of 720 is really small, 0.001 there, if I round it, okay? So using combinations within probability, we have to find the number, we have to find the total. Okay, we have to find that total. Then you have to find the successes, and then you have to do the division. So you're looking at 3 parts there. Find the total, find the successes, do the division for the probability after that. Okay, let's take a look at number 2. It says a word processing program requires a user to enter a 7-digit registration code made up of the digits 1, 2, 4, 5, 6, 7, and 9. Each number has to be used no more than once. And each number has to be used, and no number can be used more than once. Okay, so we're using every number. Okay, that's what's happening here. So, in part A, it says what are how many different registration codes are possible? So I'm using all of my codes, or I'm using all of the digits, and there are 7. 1, 2, 3, 4, 5, 6, 7. Since I'm using them all, it's just 7 factorial, because I'm not taking any of them out, I'm just using them all. So that's 7 times 6 times 5, 4, 3, 2, 1. Multiply that all together, and you get 5,040 codes. Okay, so 5,040 codes, and again, that's your total number of codes possible. Now we want to look at some different specific codes that we could get. So part B says, what's the probability? Probability always means that you're going to end up with successes out of total, that the first 3 digits of the code are even. So, let's look at what this code would look like. So if I have 7 digits in the code, 1, 2, 3, 4, 5, 6, 7, I want the first 3 to be even. I want this to be even, even, even. Well, let's look at how many even digits we have. We have a 2, we have a 4, we have a 6. 1, 5, 7, and 9 are odd. So I have 3 possible even digits for that spot. Once I use one of them, I only have 2 left. Once I use one of those, I only have 1 left. Okay, so those have to be my first 3 digits. Then the rest of these are going to be odd. I have 4 possibilities for an odd code because I have, or an odd digit, 1, 2, 3, 4 odd numbers. Then once I use one, I have 3 left. Then once I use one, I have 2 left. Then once I use one, I have 1 left. So multiply that all together, 3 times 2 times 1 times 4 times 3 times 2 times 1, and I end up with 144. So those would be my successes And then when I find the probability of first 3 even, that's going to be 144 out of the total 5,040. And that gives me, again, this is approximately equal to, which is 0.029. Okay, so let's just run through that again. I had 7 digits total, but 3 of them were even. So I had to put those 3 first because I wanted the first 3 digits to be even. That was my success. First 3 digits even. So I had 3 times 2 times 1 for the even digits. Then I had to use the odd ones after that. So that's 4 times 3 times 2 times 1. Putting all that together is 144. 144 is the success. 5,040 is the total. Do the division, and that's what you get. All right, again, we're putting the first half of this unit with the second half of the unit. So we got to refresh our memories on those permutations and combinations and then do the probability. So let's look at part C. What's the probability that the first digit is 6? So again, in my 7-digit code, 1, 2, 3, 4, 5, 6, 7, I want the first one to be, or I'm sorry, the first digit is 1. I don't know why I said 6. I want the first digit to be a 1. There's only one way that I can pick a 1 for the first digit. After I pick that 1, then there are 6 numbers left. That's where I was getting the 6 in my head. So then I have 6 times 5 times 4 times 3 times 2 times 1. So really what this ends up being is 6 factorial, because multiplying by 1 doesn't change anything for us. So when I do 6 factorial, I have 720. So those are my successes. And then the probability of the first digit being 1 is 720 divided by 5,040, which is approximately 0.143. So if you were thinking of percentages, that's kind of like a 14% chance that that could happen. And then the last question for this one, what's the probability that the code is 1, 2, 4, 5, 6, 7, 9, that they just go in order? Well, there's only one success. If I list the digits in order, there's only one way that I can arrange them that. So the probability of that code would be 1 out of the total, which is 5,040. And that is, ooh, we need more than 3 digits here because I've got a lot of zeros. So I have 0.000, and then if I round that, I get a 2. So I needed to go out further than the 3rd digit because that didn't help me. I went out to the 4th digit. So really small chance there that that's your actual code. Okay, let's look at number 3. In number 3, it says a group of 7 seniors, 5 juniors, and 4 sophomores have volunteered to be peer tutors. Mr. Domingos needs to choose 12 students out of that group. So how many ways can he choose 12 students? Well, first of all, we need to figure out how many students are there. There's 7 seniors, 5 juniors, and 4 sophomores. That's 12, 13, 14, 15, 16 total. We're talking about peer tutors in a group. This is combination because we don't care about the order. So I have 16C12, which is 16 factorial over 16 minus 12 factorial with that extra 12 factorial on the bottom. So that's 16 factorial over 4 factorial, 12 factorial. That's going to give me 16 times 15 times 14 times 13, and then 12 on down is going to cancel. But since it's a combination, I have that extra 4 on the bottom. 4 times 3 times 2 times 1. So when I calculate that, I end up with, where am I? 1,820 ways. Okay, so that's your total. Now, when I go to parts B and C, when I'm actually finding the probability, now I have to figure out how much what the probability is for each of these things. So what is the probability that he chooses 4 seniors, 4 juniors, and 4 sophomores? Holy cow, that is a lot of combinations going on. So I need to do a combinations for each one of these scenarios, the sophomores, the juniors, and the seniors. So for the 4 seniors, there's 7 to choose from, and I want 4 of them. So I have 7C4. That's for the seniors. For the 4 juniors, I have 5 to choose from, and I want 4 of them. So for the juniors, I have 5C4. Then for the sophomores, there's 4 to choose from, and I want all 4 of them. So for the sophomores, I have 4C4. I got to figure out what all those things are. So when you go through and find all of those combinations, I'm not going to take the time to do all of them because I think you can figure out how to do those, but you have to go through and find those combinations. When you find those combinations, 7C4 ends up being 35, 5C4 ends up being 5, and 4C4 ends up being 1, which makes sense because if you have 4 things and you want all 4 of them, there's only one way to pick that. So putting those together, because I need to multiply them, I want all of these things to happen. When you want all these things to happen, you have to multiply. I have 35 times 5 times 1, which gives me 175. But you're still not done. This is just your success for that probability. You still have to find the probability. So the probability of this is going to be 175 divided by the total, which is 1,820. And that gives me 0.096. Okay, now I'm done with that question. That was a lot. We needed all 3 of those combinations. That's a lot of combinations to find. So, and then part C says, what is the probability that all 7 seniors are chosen? Okay, so I want all 7 seniors chosen. So if I think of for the seniors, I have 7C7, okay? Then I have to think about the others, or the rest. I need to choose 5 more people because I've only had 7 and I need 12 in the group. So I chose 7, I need 5 more. But how many left are there to choose from? Well, when you take out the 7 seniors, you've got the juniors and the sophomores. 5 and 4 is 9. So of the 9 that are left, I'm going to pick 5 of them. Okay. Now, 7C7 is 1. That's easy because anytime you have a group that you're choosing all of them, there's only one way to do that when the order doesn't matter, of course. And then 9C5, calculate that and you get 126. So 1 times 126 is 126. That's your success. Then the probability is 126 out of the 1,820, which is 0.069 for a probability there. So about a 7% chance that that could happen. Okay, we're going to do this together one more time, calculating probability when we have combinations and permutations involved. So let's take a look at the last question. It says Diana has a full bag of coins. There are 10 pennies, 6 nickels, 4 dimes, and 2 quarters in the bag. So the first question, of course, is how many ways can she pull 4 coins out of the bag? How many ways can she pull 4 coins out of the bag? So she wants 4. There are 10 plus 6 plus 4 plus 2. That's 22 total coins. And she's picking 4. Now, she's choosing 4 to be in a group. It does not matter what order she picks them in. It doesn't say anything about putting them in order or lining them up or anything. So I'm going to call this a combination. And that means I need 22C4. That's 22 factorial over 22 minus 4 factorial with an extra 4 factorial because it's combinations. 22 factorial over 18 factorial with an extra 4 factorial. That's 22, 21, 20, 19 over, the 18 goes away, but I still have the 4, the 3, the 2, and the 1. So now when I calculate all that out, I end up with 7,315. So those are your total number, oops, sorry. That's your total number of ways to pull 4 coins out of the bag. Okay, so now let's look at part B. It says, what is the probability that she will pull 2 pennies and 2 nickels? 2 pennies and 2 nickels. So 2 pennies, there are 10 pennies total. Okay, so the 2 pennies are 10C2, 10 total. She's choosing 2 of them. Then the 2 nickels are 6C2 because there are 6 nickels. She wants 2 of them. So 10C2, 6C2. 10C2 is 45 and 6C2 is 15. And again, you have to go through and actually calculate those combinations. I'm just saving us some time because I don't think you need to watch me do that anymore. So 45 times 15 is 675. But again, that's still not my answer. My probability is 675 divided by the 7,315. And I get approximately 0.092 there. So then if I look at the next part, part C, what's the probability that she will pull 4 pennies out of the bag? Now we're just looking for pennies. Okay, we're just looking for pennies. So for pennies, I want 10C4, and that's the only thing that I have to find because I'm not pulling any other coins out of the bag. I'm not pulling out any nickels or dimes or quarters or anything. So 10C4 is equal to 210. But again, I'm looking for a probability here. So the probability is 210 divided by the 7,315. 210 over 7,315 is approximately 0.029 this time. Up there it was 9.2. So about a 9% chance down here, about a 3% chance that you'll get all pennies. And then the last one asks, what's the probability that she will pull 4 dimes out of the bag? So now I'm looking for 4 dimes. Well, there's only 4 dimes total, so 4C4 is equal to 1. There's only one way that she can pick the 4 dimes out of the bag of 22 coins. So I have a probability that's going to equal 1 success, only one way to do it, out of 7,315. And again, we're going to need some more digits here because 3 won't be enough. I'm going to go out to the 4th digit, and it's going to be 0.0001. So a 1/10 of a percent of a chance there. That's a really small percentage. So all right, so that takes us to the end of our notes for Unit 7, Note 7. This is your last notes video, calculating probability with combinations and permutations. Anytime you're picking more than one thing at the same time. So thanks for listening, and don't forget to show Miss Johnson your notes sheet, and I will see you later.